Hello, I am Trip Ware,
I'm Mackenzie Thornton.
and this presentation is on quartz and piezoelectricity in technological applications. So, we chose this topic because piezoelectricity is a form of energy generation that not a lot of regular people know about, but there's a lot of people that are looking into it as a form of sustainable energy generation, or at least talking about it like that. Um, we are going to dive into what that is, how it works, and how um, the piezoelectric effect has been used in technology, specifically with quartz or silicon oxide.
And we're also going to talk about why it's not the best in terms of substantial energy. We'll get into that later. Right now, we're going to introduce piezoelectricity, and this is known as the ability to convert mechanical stress into electric discharge, meaning that if we were to take a crystal and put mechanical stress onto it and force, it would create small traces of electricity. And this occurs through the dislocation of molecules as uh, the force is placed upon the crystal.
And so how this actually works is you have all of these atoms, you have all these molecules in a structure of quartz. And when you dislocate some of that structure, this is our intrinsic quartz. So this is a good example of a piezoelectric mineral. What happens when you move some of these, you dislocate them inwards, outwards, it doesn't matter. What happens is you create charge centers because those electrons are moving with it. So you have a charge center here, and then you have a charge center somewhere like here. And this causes an imbalance. Now, something important to know about quartz is that it has dipole polarity, and that means that it has two poles and only two poles. And so when this happens, you have electrons that are moving around, and that causes the polarity to flip. It does a total 180 on itself. And when that happens, there's so much going on with the electrons inside of the quartz unit that it causes an electric discharge. It's important to know that this is due to its crystalline lattice structure. This is a good crystalline lattice. It's a hexagonal structure for quartz here. This this is not intrinsic quartz. This is amorphous quartz. It's the same silicon oxide, SiO2, but because it is not organized enough, um, it doesn't have the same long range form to it. If you if you mess with its structure, it doesn't make any charge centers. It does not have the ability to produce the piezoelectric effect, which means that it does not flip polarity, which means that it has no electric discharge. So when you're looking at the piezoelectric effect, you need intrinsic quartz, you need unaltered quartz. Now, this effect is also best in clear quartz. You might be familiar with different types of quartz, smoky quartz, rose quartz. It's actually all just silicon oxide with different impurities from different metals that give it color. Clear quartz has no impurities in it. It has nothing else inside of it to give it that color. And that also means that it has the most perfect crystalline lattice structure, and that produces the best piezoelectric effect.
Um, the only downside to having piezoelectricity as a energy source is how much effort it takes to mine it, to extract it, to basically just take it and be able to use it. Um, the best way to extract quartz from the earth is open pit mining. That is a good way to mine a lot of materials and minerals, but it is because it's like the least costly. But it is extremely harmful to environments. You can wipe out entire biosystems. The wildlife can be all skewed up. You can lose. A lot of places have lost their some wildlife that is only found in those areas, and they've lost it, and it has died off because of open pit mining because it takes up so much area. Another thing is that with quartz, it can is definitely found there, but a lot of it needs to be It can be found in large amounts in these pits, but that just expands them more and is more harmful to the environment. That means more pollution, more um, animals being lost. But like with pollution, it's not so much air pollution, but more groundwater. All the toxic chemicals being released, all the groundwater being moved, being separated. It's not good for the environment. And then economically, while quartz, the tariff on it is 3% at the moment, it is very cheap to buy, but it is not substantial because with that it creates a lot more travel across the seas, which then the air pollution comes in with all the cargo loads, with all the flights, everything, and it is not economically sound. Um, and it is not a substantial source. So we'd have to use so much quartz and mine so much and do so much other work and effort in other areas to get even just a small amount of electricity that could charge virtually nothing. And so it's not substantial as a long time source. There has been a experiment in Japan, was it? Yeah,
Yeah, Japan.
Japan, where they created floorboards that using the piezoelectricity like effect, they tried to create clean energy by all the people stepping on them and creating mechanical stress, but it wasn't substantial because so little was being, there was so little output of an electric discharge that it didn't pay for itself. It was not efficient, and they gave up on it. So yeah.
Yeah. Even in like an urban shopping mall setting where there in Japan especially there are so many people walking all the time, all of these floor panels made of piezoelectric material, all of these people stepping on it all the time, constantly outputting discharge, it had so little output that it was not effective. That is how, I mean, that is the scale that we're looking at for this electric discharge.
Most of the times that's why it's used in small things like microphones, watches, where there doesn't need to be a lot of electric discharge, and that's why quartz watches are so effective because it's just little amounts doing a little bit of effort. But if we want to introduce this on a worldwide scale on a bigger platform, it has to be improved and refined and just innovated to be able to power large objects for a longer time than just like a few minutes. And that is where the future of the piezoelectric effect is going.
Yeah. And if we go back to the watches for just a moment, even though the electric discharge from piezoelectric materials is so small, it is substantial enough to be able to put in very, very small processing units like watches. Piezoelectric watches are different from just your standard watches because they have what's called a piezoelectric tuning fork. And it's exactly what you imagine it is. It is, this is a crude drawing, but it's literally just a tuning fork made of piezoelectric material. And what happens is you have an integrated circuit inside the watch and a piezoelectric tuning fork, and this will vibrate at some insanely specific amount. I think it was like,
It's 32,700 something hertz per second, I believe.
yeah. So this tuning fork, when exposed to electricity, will vibrate at exactly that frequency, and that's what keeps the watches so
Precise and in time.
precise. Yeah.
Every all the every second it is that frequency gives it a 1 second beat, which it then turns the second hand, and that is what starts the entire system of all the gears working. And that is why almost quartz watches you'll see windows to see all the gears because they want to advertise it. And that is honestly how the watch what are we called? The watch companies are doing it.
Yeah. Another example of technology that we use today that has piezoelectric materials in it is microphones. These are commonly called contact microphones because they require you to be on, or they require the microphone to be on whatever they're picking the sound up from. And so how those work, as a simplified version, is some sort of you have some sort of layer. This could be anything. It could be aluminum. It could be some sort of epoxy. Literally anything. Underneath it, you have a piezoelectric, usually ceramic, sometimes quartz, sometimes ceramic. So this is your piezoelectric material, and then you have a receiving material underneath it. does not matter what this is. It's different from company to company. And so what happens is you have a vibrational input, and the vibrations hit the top plate, which then vibrates, hits the piezoelectric plate. And because the piezoelectric effect actually is reversible, what is happening here is you're taking this mechanical stress, it's hitting the piezoelectric layer, and the piezoelectric layer is actually uh, it's turning these waves into electric signals that can be read. What happens then is it's just transmitted through whatever cable and reanalyzed through whatever speaker you want it to come out in. It is translating acoustic sound, it's translating vibrations into electric signals to be decoded back into sound. And it is extremely sensitive to sound because it is piezoelectric and it produces super high quality audio. A lot of guitar players actually use contact microphones for high quality audio. So, yeah, um, that's just more to say that the output on this piezoelectric effect is so small that it can only be used in small scale. So, for it to be used in energy generation, we would need a lot of developments. There would need to be a lot more put into piezoelectric studies in the future.
But going back to small scale, it is a very efficient and effective small scale because of how precise and in tune it can be. And that's why it's a really good system. Amen.